Welcome back to my channel Engineer Star. This is the question number 9 of the topic determinant, and this question was taken from the university paper that was asked in 2067 of Bachelor of Engineering. So the question is this: a square plus 1ab AC AD, and in second row BA B square plus 1 BC BD, and in third row CA CB C square plus 1 CD, and in last row DA DB DC and D square plus 1. So we need to convert this into this one. So a square is already here, B square, C square and D square is already here, and 1 is already here, but we need to convert this the product. These all are the product form into square form. So to convert the product form into the square form, like a square, B square, C square and D, we do the operation. So in first row we multiplied by a, so that it will be a square B, a square C, a square D, and a square plus 1. And similarly in this second row we multiplied by b, so b square a b square plus 1, b times bc is b square c, and b times bd is b square d, and in third row it is multiplying by c times ca is c square a, c times cb is c square b, c times c square plus 1, and c times cd is c square d, and in last column there is all d, so we multiplied by d to make d square, so it is dA times d is d square a, dB times d is dB times d is bd square, I think. This is d square b, and dc times d is d square c, and d times d square plus 1, and multiplying by a b c d we have to divide by a, so a cancels, this b and b cancels, c and c cancels, and d cancels. Now we need only a square, b square, c square, d square, not so a square is here, we don't need b, a square is here, we don't need c, a square is here, we do not need this d. So to remove this b c d and a c d and a c and d, to remove that here is all a, so taking a common from c1, here is all b, taking b common from c2, here is c in all elements, so taking c common from c3, and in c4 there is all d, so taking d common from c4, we get a b c d by a b c d, so it cancels, and 1 into determinant is this determinant, so it is a square plus 1 b c square d, a square b plus 1 c square d, and a square b square c square plus 1 d square, a square b square c square d square plus 1. The purpose of this step is to convert this product form into square form. Now what can we do to convert it into this? a square plus b square plus c square plus d square plus 1. And by looking in the this, if we add this plus this plus this plus this, that is that will be r1 plus r2 plus r3 plus r4 in r1, then it will be a square plus b square plus c square plus d square plus 1. Similarly, it will be adding all this, a square plus b square plus 1 plus c square plus d square, we get a square plus b square plus c square plus d square plus 1, and similarly for these two. So, and remaining is as it is, and taking this a square plus b square plus c square plus d square plus 1 common from this r1, so remaining is 1 and other elements as it is. Now what can we do to convert this into 0? So we need to make as many 0 as possible for our determinant simplified. So if we subtract 1 from 1, it is 0. So if we do c3 minus c1 also 0, and 1 minus 1 also 0. So in leaving this as it is, and in c2 minus c1, 1 minus 1 is this as it is, and 1 minus 1 is 0. B square plus 1 minus b square is simply 1, and c square minus c square 0, d square minus d square also 0, and c3 minus c1, 1 minus 1 0, b square minus b square 0, c square plus 1 minus c square, that is 1, and d square minus d square 0, and finally c4 minus c1 0, b square minus b square 0, c square minus c square also the 0, d square plus 1 minus d square, so it is 1. Now expanding along, we can either expand it along this r1 because here is maximum 0, that is 3 0, or we can also expand along c4 because here is also maximum 0, that is 3 0. If we expand along this, then there is only 2 0, only 2 0, only 2 0. So we have to expand in such a way that there is maximum number of zeros. So we can take either this or this as the expansion. First of all, we need to know the rule of sign, that is plus minus plus minus. Since here is plus, then here is should be minus, so plus minus plus, here is minus, so alternative plus minus plus minus, so plus minus plus minus plus. So by this way also it is plus minus plus minus, by this way also it is minus plus minus plus, and by this way also minus plus minus plus. So so this is the, we have to remember this sign. So if we expand along this, so it will be 0 into determinant of this, that is 0, so minus of 0 is also 0, so and taking positive sign, and if we take this, then we have to remove this row and this column and this row, so 0 into something is also 0, and if we take this, then we have to take negative sign, and minus 0 times something is also 0, so remaining is 1. So if we take 1, then we have to cancel this column and row, and remaining is this, and this is a bit difficult, so we don't choose this, and we choose expanding along this r1 because it also have 3 0, so expanding along R1, the for this position it is 1 and 1, so it is positive plus 1, so and cancelling this column and row, we get the determinant of this. So by looking at it, we realize that it is an identity matrix of order 3, because there is 3 row and 3 column, and there is 1 in diagonal and 0 in elements except diagonal, so it is of order 3 by 3. This is of order 3 by 3, so the determinant of identity matrix is always unity, so 1. So it is, so 1 into 1 is also 1, and 1 into this whole is 1. Sorry, this a square plus b square plus c square plus d square plus 1. So by this way we can prove the determinant. So this was in this video, and in next video I will discuss the expansion of question number 10. Thanks for watching, and like and subscribe the channel.